In the previous tutorial, I talked about deriving river network and watershed. So here it will be more of calculating the statistics. Example, we can count the number of streams in each stellar order and its length as well. So I have used the what you call Amochu River Basin as my study area, and then I want to count the number of streams in each stellar order in this particular river basin. So from your streams, I have basically clipped for my specific region of interest or for specific basin, that is for Amochu. Once you are done that one, so you will look for statistics in processing toolbox, and then you will click on statistics by category. So your input vector layer will be the tributaries or the river networks that is of your particular river basin. To field to calculate the statistics on as length, I want to calculate the length as well as of each stellar order. For example, in stellar number 1 there would be around 20 to let's say 2000 streams, and then I want to calculate the length of those 2000 streams. And then fields with categories as order. So in this particular column known as order, I have the stellar order from 1 to 6, and then I can just click run. Just close, and then if you open the attribute table of your statistics by category, now you can see out here. So stellar number, it ranges from stellar number 1 to 6, and then the count here represents the number of streams in each stellar order, and then sum is the length of those number of counts in stellar number 1, and then it is in meter, so I have to convert it into kilometer when I want to calculate the bifurcation ratio. So to calculate the bifurcation ratio, either I can do out here, or for my convenience I will take this as a Excel in my desktop and then do the analysis. So I have placed it out here, or I have saved in my desktop to calculate the bifurcation ratio. So to calculate the bifurcation ratio, what are the information that I require is, example, name of the basin, then the area of that particular basin, then I want the stream order, that is stream order 1 2 3 4, the number of streams in each stellar order, then I have to calculate the bifurcation ratio, then stream frequency, length, drainage density, and then mean stream length. So I will have, let's say, name as Amochu. Then I will extract the area of Amochu from here. If I open the attribute table, so here I will go to fill calculator, then go to create new. So to calculate the area of a basin, you will go and open your study area or your river basin attribute table. So here you will see FID, DN values. Since it is already being calculated, it is showing out here. To demonstrate how to do that, you will add field, you will go to field calculator, then create new field, and the name is as maybe area underscore square kilometer. Then your output field type should be decimal number, and then go to geometry, and then under you will enter, press double click on $area to be appeared out here in expression, divided by 1 million to convert from meter to square kilometer, and then you will click OK, and then it appears out here. So Control C, copy, and then paste out here in your area. So this will be your area. So stream order or stellar order, which you can see out here, stream order. Okay, fine. So count means number of streams. Okay, from here it is not organized in the logical order. You just copy and then let's say paste. Control Control C, paste out here, and then order number 1, order number 2, order number 3, order number 4, order number 5, and then order number 6. Then you should also have the length in kilometer. So you go there and then select, so just delete these fields to make it simple. Control C, again somewhere here, Control V. So stellar number 1, it's in length, you have to convert it into kilometer. The length is in meter, you have to convert it into kilometer. And then this is for 3, this one is for 2, this one is for 6, this one is for 4, and then this one is for 4. So equals to, oh wait, just do it here, equals to length divided by 1, 2, 3, 4, 5, 6. Okay, length in kilometer. So to calculate the length, to convert the length from meter to kilometer, equals to the length in meter divided by 1000 will give me in kilometer. Okay, so you are done. Now you have to calculate the bifurcation ratios. So to calculate the bifurcation ratio, it is quite easy. Equals to the number of streams of first order divided by second order will give me the bifurcation ratio of first order. Then to calculate this, do the same, divided by third order equals to this one divided by this one will give me, okay, equals to this one divided by this one equals to this one. Okay, then and then you have to find the average, equals to AVERAG, average for the highest stellar order. So you can see the bifurcation ratio of each stellar order. Now you have to calculate the stream frequency. So to calculate the stream frequency is Fs equals to n divided by A, that is n is number of stream divided by A, that is area. Okay, equals to n divided by area, and then press Fn plus F4, Fn plus F4 to make the value, or to keep the value static. Stream frequency. Okay, so you have the stream frequency, then length, and then drainage density. Okay, to calculate drainage density is length divided by area equals to length divided by area. Again, keep it static, press Fn plus F4. Okay, drainage density. Okay, then mean stream order equals to L divided by N. L is this one divided by, where is N? Length divided by number of streams in each stellar order. Enter. Then you have the detailed information out here. So you can see here, name of the river is Amochu. Area of this particular basin is 3766 square kilometer. There are 6 order of streams, and then in each order of stream there are number of, in each order, stellar order, there are this many number of streams. Then the bifurcation ratio for each stream order, and then the stream order, each bifurcation ratio for number of streams. Then you have stream frequency, then you have the length, then you will calculate drainage density, and then mean is length. This all.